Hey everyone, how are you out there? This is me, Sarah Fuentes, your math specialist. My camera is a little bit different today, so I'm making sure I'm looking in the same place. But first, let me just make sure I add on my group for math tutoring lessons because they are amazing, and I want to make sure that they also have the opportunity to jump in on some of these lessons for today. Okay, so I added them in. Hopefully they're able to watch and see what's going on for today. Posted, awesome. Okay, so like I said, Math Marvels, welcome back for another math mini lesson. I had a tremendous week, really busy. If you were in New York, you know that spring break was canceled, and for many of us who observe religious holidays, this was really hard for parents. I know this is challenging, but it is all in the effort of continuing social distancing. So yes, distance learning is really hard, and it's definitely a challenge for all of us. We are all struggling to figure out how this will go. So I really started to think of what are some things that I'm noticing trend-wise. And lots of people are asking me questions about multiplication, division, fractions. They come up all the time. Most popular topic keeps coming up. And some parents ask, should I just have my kids memorize their times tables? Will that be the best way to go? And my point of view is, if you want to be really good at times tables and knowing your division facts, your multiplication facts, in order to do things like simplifying fractions, like when you have to factor polynomials, when you get to these higher levels of mathematics, you have to build what's called number sense. Like, we all know what money sense is, to have a good sense of how to use money, how to make it work for you. But not everybody knows how to actually work with numbers in a proper way, and how to develop that sense of pattern seeking with numbers that helps us kind of work faster with numbers. So I thought today, why don't we do some work around numbers? And I've done this with 4th and 5th graders, even 6th graders. Hi, Jamal. And we're going to use this lesson to kind of build up some foundation work into what you can do with other numbers. Okay? All right, so I'm going to flip the camera because you're going to see my desk. And we're going to do something a little different. So this is my workstation desk. And I have, today what I have lots of, don't mind them combing makeup, lots of markers, dry erase markers. And I have these. These are called square inch tiles. And you can get them on Amazon. I got them for about a huge bag of them for $10. This was the station hand to mine. But you don't need these for today's lesson. You can actually do them with pennies or coins for today. So we're gonna have some of these. And I also printed out some square inch grid paper. So we're gonna take a look. And we're gonna jump into some 100 squares, and I'm gonna ask you to start thinking about some patterns when we do some skip counting. And this usually starts at a really young age. And all we're gonna ask you to do is, when you have this 100 chart, and you can make this, if you're a parent, you can easily make it from home. You can just make one of these. And what you're gonna do is you're gonna ask a kid to start from, I'm starting from 2, and we're just gonna skip count by 2s, and I'm just gonna color in the 2s. So 2, 4, 6, 8, 10, and some kids will just go like this with their finger, and that's okay. That's what they do. And you're gonna have kids continue on the pattern, and they're gonna keep counting 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. And then I'm gonna just stop there and just start asking kids questions like, what do you see and what do you notice? Let me see if I can make this a little bit closer. So if you're in a family, you start asking yourself this question: what do you see and what do you notice in your numbers? Just gonna move the lighting over just a little bit. And most kids will start saying that they notice that it's starting to make a really big straight line. And we'll start asking, do you think this is gonna keep going? Hi, Billy, welcome. Let's see if it keeps on going. If a kid keeps skipping 32, 34, 36, 38, 40, they're just going on with this pattern. And you can start to make certain trends. Like, most kids will just start doing this without even thinking. Hi. And I'm like, yeah, I can kind of just make the whole thing. and I know it's going in a straight line. And so even though kids are just counting by twos, it's kind of like when you're playing a video game in the beginning, you start thinking, but then you pick it up really fast. A kid is going to see this pattern, this linear pattern. And then you can start asking your kids some bigger questions. You can start asking them, well, what do they see and what do they notice besides the straight line pattern? And some kids may also notice, well, all of these end in 2s, 4s, 6, 8, and 0. So all the numbers I colored, they all end, oops, in 2, 4, 6, 8, and 0. And any number that ends like this, well, we have a special word for them. We call them even. And the reason we call them even is when we have those numbers, like here's 2 and 4, I can make them into even pairs, like everyone has a partner. As opposed to if I had 3, if I tried to make 2 rows with 3, someone's left out. I have a number that just doesn't have anybody, so that's odd. So that's an even number, here's an odd number. So we can really see when we think of our 2s, we can see all the even numbers. And that's where this part starts to make sense. And you can even keep going, and I do this a lot with kids. And this definitely happens with younger kids. You can have them try it out with other numbers. And some numbers are going to be super easy. I want to kind of leave 2 in a place where we can see it. And some are going to be a little different. So, oh, thanks, Billy. I know so many people are just doing videos and it makes teaching kind of hard. So I thought doing something hands-on video would be really different. So we're going to try doing something with the 3s. Same thing. We're going to count by 3s. 3, 6, 9, 12. Oh, I almost put 14. 15, skip to 18, 21. And I tend to stop around 30 just so we can stop. And I always ask kids, what do you see? What do you notice? So just looking here, some kids start to say, well, I notice that some numbers are even, like 12 and 6 and 18, and some numbers are odd, like 9, 3, and 21. So there's a difference happening here. So it's not exactly like the 2s. So we kind of keep going. Plus 3, 33, plus 3, 36, plus 3, 39. And we keep on adding 3s. And if you see something or notice, feel free to chime in until you start to see or develop a pattern. Because remember, that's how our brain works. Our brain starts to see patterns. That's how we were created, to notice things. So as you're going through here, you're probably going to start seeing, oh, it's diagonals. I can just color the rest of these. I'm like, yep, you can. So you see a diagonal pattern. And then I would ask kids to push a little bit more and think about the numbers. Is there anything else? We know that it keeps on going. There's even and odds. Matter of fact, it goes in a pattern. Odd, even, odd, even, odd, even, odd, even. So it's skipping a lot. And there seems to be that pattern. But there's this other pattern when we think about the numbers. I'm going to ask you to look at this front row here. And think about these numbers and the digits. 3, 12, and 21. What do you see and what do you notice? Just thinking about the digits. 3, 12, the 1 and the 2, and 21, 2 and 1. I notice that all of these have digits that add up to 3. 1 plus 2 is 3, 2 plus 1 is 3, and I have 3. And then the same thing here. Is there a pattern in this row? 6, 15, 24, 33, 42, 51. I start to see that same pattern with the digits. 6, 1 plus 5 is 6, 2 plus 4 is 6, 3 plus 3 is 6, 4 plus 2 is 6, and 5 plus 1 is 6. It even starts to repeat here like, okay. So there's something happening, and you can ask, is it always true? And you can see it here too with my 9s. They all add up to 9. 9, 1 plus 8, 9, 2 plus 7, 9, 36, 45, 54, 60. All these add up to 9. So what do you think is going to happen here? So we had 3, 6, 9. So would this be 12? No, because it has 30. So it's 3. 3 plus 9 is 12. But 1 plus 2, that makes 3 again. 4 plus 8 is 12, but 1 plus 2, that makes 3 again. 12, and 1 plus 2 makes 3. 12. 12, 12, 12. So I'm noticing certain patterns happening here. And as we're developing that skill, kids start to notice certain things about numbers. All of these are multiples of 3. And there is a pattern with sums. Hi, Danishka. Hi, Danielle. Welcome. The sums, the digits of the sums, they add up to 369. And I always remember that song, 369, the goose drank wine. And I don't remember the rest of it, but I always remember 369. So just looking at these two numbers, look at how different the patterns grow. And so I know something about the multiples of 2. They always end in 2, 4, 6, 8, 0. So anything that ends in these numbers, that means it's a multiple of 2. It also means I can divide it by 2. That's the other thing. It means they're divisible by 2. Anything that I made blue is divisible by 2. I can divide any of these numbers by 2. And the same thing is true for everything here in red. Anything I colored is divisible by 3. So these are just some terms I want you to think about. I have multiples of 2, and I can recognize what is divisible by 2. I have multiples of 3, and I have numbers that are divisible by 3. So I can break these numbers up. So I'm going to put those 2 words in kind of in our mind, our vocabulary. And I want you to think, what other number patterns do you really know? Like when you think of your times tables, which are the easiest ones? The ones that all kids know. And you're probably going to say your 5s and your 10s. Those are the easiest ones. So when I think about why kids struggle with the multiplication tables, they don't struggle with all of them. They only struggle with some of them. So 2s and 3s tend to be easy. Why are 5s and 10s also easy? Why do kids love the 5s times tables or even the 10s times tables? And it's because these numbers, it's really easy to see the pattern. If you count by 5s, you're just going 5, 10, 15, 20, 25, 30, 35, 40. You're just skipping and skipping and skipping in the same way. So 5, 10, 15, 20, 25, 30. So automatically you're seeing that it's always a number that ends in 5 or 0. So that's what makes these easy to remember. That's why all the kids that I wanted to be called, when they asked me to say my times tables, I definitely wanted the 5s. So anytime I see a number that ends in 5 or 0, that means it's divisible by 5. Okay? And then why do kids like 10s? Because they all end in zeros. That's why tons of kids love their 10s. They just think to themselves, oh, 10, 20, 30, 40, they all end in 0. So there's always this last line that we always see. And so if you have kids, and especially when they're young, you can start doing this type of pattern work. I just went online and I just printed like a 100 squares chart. Just make one of those. And you can find those and you can make these with your kids from home. And you can have them start looking for these patterns. And you can start giving them these terms. And start using them with kids. You can start using terms like multiple. It's kind of like you're making a lot of copies of something. You can use divisible, which means you can share that number. And you could even use words like factors. And factors are other ways you can break up numbers. You can break up or you can organize them. Okay? And you can do this for all kinds of numbers, not just these. These tend to be the easy ones, 2s, 3s, 5s, and 10s. But the ones that are harder are usually like 4s, 6s, and definitely 7s. So if you're a parent, you're like, so Sarah, what do you do? Should I just have my kids memorize it? I would honestly say memorizing is great for some kids. It is not great for others. So you may want to think about what strengths do your kids have. What is your kid really good at? How does your kid learn best? What are your kids into? And I will tell you, if you go on YouTube, there are tons of songs to help kids memorize. So for example, here's a sevens song that I was able to find, and it's using Just Pharrell's Happy. You think that you can multiply, because I'm happy. 7, 4 to 21, 28 to 35, because I'm happy. Category 42, 49 and 56, because I'm happy. 63 to 17, 77 and 84. Yeah, and you can find tons of videos like this to help your kid. I saw a really cool one with threes, where someone used Bruno Mars to make threes. And that was another creative one. Let me see if I can find it. Threes and Bruno Mars. And there are so many amazing teachers out there who come up with these videos and who make them for their kids. And the trick is, they know that if they do this, see, threes, Uptown Funk. They know that if they do this for their kids and they commit, their kids will not only buy in, but they're probably going to listen to these songs again and again. They're going to try these things out, and they're going to know this more. They're going to pick it up faster and practice it faster. So this is another really cool teacher. I love teachers. They're really funny and creative. And his whole school is involved. And you can hear when he gets into his threes. Dun, dun, dun. That 3 times, that 3, 6, and then 9, that 12, 15, 18, 21, 24, 27, 30. We're counting, so astounding. I can count for threes in my sleep. So simple that I think y'all see the world now in 3D. Times 2. Okay. So huge shout out to my other YouTube teachers out there who are all creating new content and doing things for their kids. They're making math fun, and the more fun you can make it, the more likely your kid's gonna remember it. And that's way more fun than just memorizing these things. So that's why I kind of love this. So this is one thing you can clearly do with any kid. And I would even push you guys, if you started these, what do you think the 4s will look like? So what are some things you're gonna look to see? Like, is it always even or odd? Are there any patterns? And I started it with 2, 8, 12, 16, 20. If you were to continue, what patterns do you think you're gonna have? What do you see? What do you notice? You may see something that I don't even see yet in numbers. And you can even try it with the numbers that are the hardest ones, like 6 and 7. Try and see if you notice any patterns with them as well, if you notice anything. And let me know in the comments what you think, if you found something interesting. And again, if you're thinking about building on with this with kids and helping them to memorize, you can use songs. Use YouTube. You do things that are just easy for them to just pick up with rhythm and sequence, because that's how your brain works. Now, the other thing I wanted to help you guys out with today was doing some, I was trying to make a little math museum. And this is something I did with 4th graders and 5th graders. And I needed something that I can kind of make into an array. So that's another word you're going to need for today. An array, and I'm going to put it up here for you. An array is a rectangular arrangement. Okay, that means I have to make it into a full rectangle, full rows with no odd numbers, nothing left out. That's what I want to be able to make. And when I used to make this, when I would make my little family, I would try and push kids, and I would give them a number, and I would ask them to make different arrangements with it. So I'm going to try this with some tiles, and let's start with some easy numbers like 1, 2, 3, 4, 5, and 6. And what you do is you can do this with pennies. Grab some pennies or anything that's quick and easy for your kids. And so let's say I'm using one of these. There's no other way I can rearrange this to make anything else. So this is my only arrangement, my only array with one tile. So I just have one group of 1 or just 1 times 1. If I want to have a discussion of my factors, the only arrangement I have is 1. Okay? Let's try with 2 tiles. Okay? I can make a rectangle like this, or I can make a rectangle like this. But notice it's kind of the same rectangle. It's still a 2 by 1. So it doesn't change even if I flip it around. So my only arrangement is a 1 by 2. And so my factors are just 1 and 2. All right, try it out with 3. So here's 3 pieces. I'm going to try and make a rectangle. Okay, I can make a 1 by 3. I can't make a second row because I don't have enough. So I just have 1 times 3. So my factors are just 1 and 3. And remember when we talked about factors before, that means I can divide by those numbers. So I can divide 3 by 1 or 3 by 3. Okay, so I'm going to keep doing that. I want to move these a little bit just so I have some space. Because when we get to higher numbers, like right now, these are nice and small numbers. They're easy. I like working with these numbers. So here's 4. And because the numbers are going to get long on my table, it's going to be hard. I'm just going to do it this way. And is there any other way I can use 4, make 4 into a rectangle? Yeah, I could do this. This is a rectangle, a 2 by 2. It makes sense. So I'm going to put these 2. So those are the only ways I can make rectangles with 4. And I let kids do this. I let them play with it and try and make as many as they can. So I can do a 1 times 4 or 2 times 2. So that means my factors are 1, 2, and 4. I can divide by any of those numbers. And what we know about 5 is 5 only makes 1 times 5. It's the only way I can divide 5. So we notice these things with numbers, and I start to ask kids things like, well, what do you see? What do you notice? Let me move this over just a little bit for space. And I ask kids, well, again, what do you see? What do you notice? And some kids go and they notice that, well, some numbers only have 1 arrangement, but 4 is different. 4 has 2 ways I can make it. And so we have special names for these numbers. So for these that only have one arrangement, we call those prime. And they're prime because I can only arrange them in 1 way. And notice the only factors I really have are 1 of themselves. That's why they're prime. But 4 is composite. And kids start to pick that up, that this shape is different. And so we give it a special name. It's a composite because I can make other arrangements. So if we were doing the same thing with numbers like 6. And again, your fact families can really help with this. What do we know about 6? How can we make 6? Everyone figures out the 1 times 6 because that's always the easiest one. And I always get kids who ask me that. And they'll pick it up fast and they'll go, oh, it's just 1 times 6. Yep, and they can make that for every single number they have, 1 times 6. But are there any other ways? Can they make 2 rows with 6 tiles? And so I give them 6 tiles and they try it. And they're like, yeah, I can do this. So then I would ask the kid a question like, so then is this prime or composite? Is it? And they'll have to look back and they'll start referring and going, well, these are prime. This is a prime. This is a prime because there's only 1 way to make it. But 6 cannot be prime. Can't be prime because I have 2 ways. And then I might tell them something with 7. And some kids will start remembering things like, oh, wait. Let's go back to this list for a minute. There's something about 7. So I'll give them 7 tiles and I'll ask them to predict. And they'll always say, we know we can make 1 times 7. 1, 2, 3, 4, 5, 6, 7. They know this. Can they make 2 rows with 7? And they may make the connection, no, you can't because it doesn't end in 2, 4, 6, 8, or 0. So I already know something about those numbers. Every number that ends in 2, 4, 6, 8, 0, I can make into 2 rows. But I can't do it with 1, 3, 5, 7, and 9s. I can't do it with my odd numbers. So kids pick up on this and they start having fun and this is how you start growing their mind. So with 8, we already know you're going to get 1 times 8. We already know it. I don't even have to draw it because everything has 1 times that number. But because it ends in an 8, I know I can do 2 times something. 2 times 4. And so kids get that. and they start to, once they start to recognize and they build this number sense, they start to make predictions, and they don't necessarily have to build in the same way. And that's what you want. That means their brain is really working. Oops, I hit the little camera pod. And you can start asking them things like, well, what do you think about threes? Can I make 3 rows with this number? And again, think back to your patterns with threes and what we saw. We saw that with threes, only numbers that added up to 3, 6, 9 could make rows of 3. So I can't do it with 8, but I know I can with 9. And so kids will go and they'll try the same thing with 9. And I'm going to tell you, I did this live with kids, and it would take us 2 days if we go all the way up to 40. And all we would do would just explore numbers. And kids would always they can do 1 times 9. They couldn't make rows of 2s because it's not even. So they would know that. They would start using these terms. And they would go, oh, I can definitely do 3 because it's 3, 6, 9. It ends in that. And then there's another special number, special pattern they start to see. And start looking, and you might be able to see or notice something. You might notice that there are some cases, like with 9, here's 3 times 3, and like 2 times 2. There are some numbers that make a square, and that's why we call these guys square numbers, because the arrays make a square. So you can see how like I can take a really simple exercise, and it's a low, we call this almost like it's a low level, but I can go really high with it, high ceiling. So there's a low floor, everybody can try this, but then I can get really big and go up to big topics. Like talking about square numbers is something that you get into when you're older, but a lot of people don't recognize it's because it literally makes a square. Same thing with 4, it makes a square. 2 by 2, that's a square number. So again, low floor, high ceiling. I can go into this, and hi Julie, and I can just start looking at numbers and discovering all kinds of different patterns. And you start to see things and wonder with these. And when I was doing this in my classroom, I would literally give them square inches like this, and literally we would take these, right here's for 6, and they would take them, and after they explored, they would cut them out, and I would have them put this on a piece of paper, like on some type of background. I had made one. Hold on. And we would literally just glue it. So we would hang it up. I would just have them put the fact families here, and they would put them up, and we would just remember, we would hang these up around our classroom, and we would look at every single number all the way to 40. And because I had a lot of kids, if I had 25 kids, everybody got 2 numbers, and everybody participated in our math museum. And so we had a museum of numbers, and we can look for patterns, and we can look to see, what do we see, what do we notice? And kids always picked up on certain things, that they can start identifying which ones are our prime numbers. And prime numbers, again, were easy to spot because our primes only had 1 arrangement. Like 5 is a prime. So on that poster, this is all you got. Like a 1 times 5. So they could see, oh, just by looking at that prime, this is composite. And kids just picked up on it. And so when it came time to simplify fractions, when they had something like 2/5, they already knew, oh, I can't simplify this 5 because it's a prime number. Versus if they had 2/6, these are both composite. Oh, they're both even. That means they're both divisible by 2. And that is the beauty of number sense. Number sense is building onto this understanding of numbers. And if you can have a sense of, are these numbers prime or composite? Are they divisible? Are they multiples? If you get this sense of it, it makes some types of topics like multiplication and fractions so much easier. So I hope that this is pretty helpful. I'm going to switch views for a little bit. I hope you found that really helpful. This was an activity, again, I did it with my class, with my kids. They would all participate, and literally my entire classroom walls were just filled with numbers all over the place, and it was so much fun for them to build something together. And if you are a parent at home looking for things for your kid to do, again, you can do this with pennies. You do not need the square inch tiles that I have. I'm a math geek, so I kind of have a lot of teacher stuff, but you can just use whatever you have around the house to make these arrays. So Again, key vocabulary words that you want to develop: arrays, arrangements, multiples and factors, divisibility, and if we think of any more, well, prime and composite. You can start building those in your conversations. And the more math talk kids have, the more comfortable, the more meaning they create in their mind. So my little math marvels out there, I hope you enjoyed this. If you have other topics you would love for me to explore, please, by all means, just add them to the comments. Let me know, give me pictures of homework. I will be more than happy to explore them with you. Okay, so take care. If you want to get in contact with me, please join the group. I have videos, but I'm definitely looking for more problems to help out. So, all right, well, that's it for today. Bye, guys.